Okay, so now nuclear physics. Actually, nuclear physics, you take out this one also. Pick up the module interventions. Module intervention, page 117. Oh, okay, record already. Okay, everyone, please take out your module physics and module intervention. Okay, so this is this one you already learned in Form 3, Chapter 8. So you learn alpha, beta, gamma. If you forgot, just a very quick revision. Uh, alpha, beta, gamma. Alpha means it's a positive particles that will radiate, that which have radioactive ray, means it's harm to human cell. Negative beta actually is an electron. So actually it's much more smaller like this. It's negative. Gamma is a ray, means it's a wave. Okay, since we have learned chapter 7, actually a wave could have particles duality too. But now we just treat gamma as a wave. Now just treat gamma as a wave. Hi, Aiden. Okay, so let's see one very short video to recall the alpha, beta, gamma. Just very short. Okay, it's from 3. I save in Form 3, Chapter 8. So today, so you can see radioactivity means something is emitted up, like this. This atom is aching. Something go up called radioactivity, and it turns to another thing. The nucleus is much more smaller than an atom. Why carbon suddenly become neutron? That's right. Carbon suddenly become nitrogen. Okay, so this one is, it is about the atom, means you learn in chemistry. Okay, let's see this. This is a fate simulation built in atom. So see, this is, we name the atom by the numbers of proton. By the numbers of protons. See, no matter how many neutron or electron, it won't change. Okay, so now it's a stable carbon. Okay, so actually the carbon just now in this video, why carbon emits out electron will become nitrogen? That's because of this electron is not coming out from original electron. Actually is this carbon, it will take out one neutron and split it up. Okay, this neutron split up become one proton and then one electron up. Okay. So actually is one of the neutron split into one proton and emits out one electron. That's why carbon become nitrogen. Okay, so the electron that split out, we call it as beta. Okay, and if they split up, okay, so the beta is radioactive out from the atom. Then this one, this alpha actually is a helium. This alpha actually is a helium ion. Then what is 4,2? Actually, it's according to your periodic table too. Where's my periodic table? So actually, alpha is helium. Where is it? Oh, here. Helium ion means it does not have electron. Inside got two proton and two neutron. So totally the charge still positive lah. Okay. Then gamma is a ray, is a wave, so we call it as a neutral wave lah. Okay. So it's positive, it's negative. So now from the radioactive source. So actually this one comes from where? I can show you that actually come from any things. Okay, so we can use this plug chamber. We don't study that. You just need to know this solid straight line is alpha. Then this is beta, and the dot is gamma. Okay. Thank you, Samantha. So I should tell you that one radioactive substance, it can continuously emit out alpha, beta, gamma. Some may be just emit out alpha and gamma, but it could be alpha, beta, gamma together. Okay, then why I show you this? Because I want to tell you the Geiger-Müller meter is counting the radiation. We call it as radioactivity. Okay, we call it as radioactivity. Means in 1 minute, got how many radiation is detected. So we call them as radioactivity. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 counts of radioactivity per minute. Now can get the idea of radioactivity. me some response. Can give me some response. Can understand that radioactivity. Thank you, Aiden. Thank you, Jinyan. Thank you, Charlotte. Thank you, Savindra. Thank you, Madam. Because in the class, I can see your face. If your face, I understand now, you don't understand. Then if your face, then I know that majority of you understand. Okay, so now you can see that the radioactivities from different, sometimes more, sometimes less, but it will count within 1 minute the average. Okay, so it's like, let me show you five. Actually, all of this, I consider you already learned in Form 3, you should know. Okay, so but I need to remind you, recall that you all recall. It's not this. How to use it? Geiger Müller. This is the radioactivities. This one is average in hour, some in minute, right? So then can see this is the count. Okay, now here got beta. This is carbon 14 and cesium. Both of them will give beta particles, beta radiation and gamma radiation. This is cesium. So carbon 14, you all know lah, used in Sejarah for what is it called? Carbon dating. Yeah, thank you, I did. Okay, here the Zagi means a lot of radiation come out lah. Why they use bare hand? Because this one I think still very weak. So with this distance still cannot make any harms. This is another radioactive substance. So I want to show it will be blocked by, let me see. I think it's this. This is alpha radiation. Oh yeah, by the way, even though without this radiation, you also can hear the sound ding 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 ding. Okay, because we got background radiation. Means like the wood also will give radiation. But this radiation, don't worry, is non-ionizing. Non-ionizing means not harm to cell. It won't kill your cell. Okay? So you learn chemistry, you know that ionizing means electron is taken out. So actually, so ionizing means you take out atom. Like you take out electron. See now balance. You take out you ionize means you take out electron, means you spoil the atom lah. When you spoil the atom means it can spoil your cell too lah. Okay, so now But alpha, a paper can block already. So no more. You can hear the sound lah. The sound reminds you there is activity, radioactivity. Now this is beta radiation. Paper cannot block. So higher penetration power. But the glass can block. Okay. Aluminium also can block. Okay. Gamma ray, we need the thicker and denser media metal. Paper glass also cannot block, so penetration power higher. This is lead or concrete. Concrete means our wall. Okay, but thin also cannot, must be very thick lead, then only can block. Okay, so now that's alpha, beta, gamma. Okay, now let's look at this book. So now can you see if we set up the metal plate with this is connected to negative terminal, means terminal means the battery side lah. Okay, so this is positive terminal. Means beta is negative will be attracted to the positive plate lah. So this is our sorry. Beta negative will be attracted to positive plate. So this is beta lah. So positive alpha will be attracted to negative plate, but gamma is neutral, go straight only. Right, so now name the type of radiation. Y is gamma. Y is gamma. Z is beta or beta. We always say beta because kerajaan beta. Okay, give one reason why deflection Z is more than deflection X. Here, be careful. Deflection. What's the meaning of deflection? Okay, deflection means it will be, I forgot in English is what. That's right, in Chinese, deflection. 偏向偏转 means it will sengit. So which one sengit the most, the X or the Z? So actually, if I mirror it up, if I mirror it down, so this X, I mirror it down. Okay, let's say X like that. Which one deflect more, Z or X? Let's just compare Z and X. How to see which one deflect? Can anyone tell? Which one deflect more? Which one deflect more? X. Thank you, Tina. X 1 vote. Anyone? Z. Thank you. Anyone? Okay, so actually it's Y. Y does not deflect lah. Y go straight only mana ada deflect. Deflect means 偏向，它歪掉了，不正，它歪，哪一个歪掉比较多？Which one more? 那一个 y 多一点 y 掉了thank you Bethany. Yeah, actually it's Zach. Zach sang it more. This one not saying it at all. So we say this one no deflection. Why I keep mentioning this? Because there will be about I saw two types of deflection question before. They are asking which one deflect more. Three types. For example, this is a galvanometer. Galvanometer is 0 at the center, and -1, -2, -3, and 1, 0, 3. The galvanometer, -1, -2, -1, 2. Okay, so now set this is. So can you please tell me A, this is the center, A or B deflect more? Like, please choose. Just choose. Yeah, thank you, Bethany. The rest. Thank you, Taishon. Thank you, Ichan. Thank you, Savendra. Thank you, Andrew. Thank you, Kelly. Yeah, see? Okay, deflect. And one more is in chapter 5 about thermionic emission. Also, got question about deflection. They will ask which one deflect more. Okay, deflect more means we can compare without with no deflection one first. So of course X will go further than only deflect, then only white tail. Only the deflect Deflect means white tail or saying it. And this one, wow, go a little bit already saying it. So actually it's Z deflect more. Okay. So it's a very small part, but many people wrong because of this small part. Okay, for that you hear. Okay, so now the deflection of Z is more than deflection X, correct? Because Z is alpha, is beta beta smaller so alpha is bigger. So we say mass of Z is 1. Okay, so now radioactive material emits harmful radiation to our body. Suggest one precaution to be taken when handling radioactive source. Can I say wear gloves? Glove cannot. I show you what glove cannot wear. Yeah, cannot. So we can say we use forceps. Use forceps. Apa itu forceps? Kep. No. Everything cannot. Kep. Yeah, kep. Forceps. Forceps to create radioactive substance. Why no one? Forceps. Okay, forceps. Claw. Yeah, claw. Something like claw. Yep. To take. Yeah, I don't know why every time I cannot search one forceps. 爱乔恩，我看到你。Okay, forceps. Okay, forceps. Give one reason to to protect our hand from ray, radioactive radio ray radioactive radiation. Okay, radioactive radiation. When I talk about alpha, beta, gamma, actually I'm talking about radioactive radiation most of the time, alpha, beta, gamma. Okay, I say radioactive radiation or I just say radiation. I'm talking about alpha, beta, gamma. Bear in mind. Okay, so now I've come to this. The equation below represents a reaction of radioactive decay process that produce particles P. Actually, we also learned it from 3, but I bet you forgot it. So actually, it's quite easy to do this question. You can see this is 226, this is 88, this is 222, this is 86. So can you see? You treat upper part. So you treat the P actually is P with upper part. We call it as atomic number. Atomic number. 88 is called nucleon. Nucleon number. Yeah, correct. I did 2E. So we treat them in the same phase. This is, let's say this is X and this is Y. Okay. So means we can make it as, you can see, before reaction, we call it as material. After process of chemical or something change, we call it as product. So actually, material always equals to product. I mean the number. So we can see here, we make an equation 226 equals to 222 plus x. So x equals to 4. Then down here we will get 88 equals to 86 plus y. So y equals to 88 minus 86, 2. So we can get a conclusion. This P has 4 atomic number and 2 nucleon number. Sorry, I'm sorry. My fault. Sorry, I say something a little bit. This is nucleon number. Nucleon number means the number of proton plus neutron. This is actually electron number. Sorry, proton number. Proton number lah, P lah. Yay! Thank you, Dylan. Thank you, Liang Zi. Yes. 42 means it's a helium particles. So you can say it is a helium nucleus. Nucleus. The center got 42. Only got 4. Sorry. 4 means got 2 neutron and 2 proton. 2 become 4. So this is total 4 lah, then proton got 2 lah. So you can say helium nucleus or alpha. Yeah, alpha. Okay, then this radioactive decay process, we also call it as alpha decay. What's the meaning of decay? Decay. Cha-cha. Can say cha-cha. Decay means cha-cha. It becomes cha-cha. 残缺衰弱. So it becomes cha-cha because they emit out one alpha particles. So we call it as alpha decay. Okay, so if emits out beta means beta decay. Emits out gamma called gamma decay. Okay, then behind we are going to, so actually got 1, 2, 3, 4 called nuclear fission, and number 5 nuclear fusion. Okay, we got 5 processes now. Okay, so now okay, so this one, just now I want to show you. I want to show you from the tree. Okay, so alpha actually bigger because it's a helium nucleus for 2. And beta is an electron, much more smaller. So this emits out alpha, we call it as alpha decay. Emits out beta, we call it as beta decay. Okay, so actually this is the change of carbon to nitrogen. Okay, alpha is 2 proton, 2 neutron. Okay, alpha is a helium nucleus. So alpha stopped by paper, but beta can pass through paper. Okay, gamma is a wave. So gamma also can kill the bacteria or kill cancer cells, right? So now, so alpha because so can cause highest ionization. You can see 3 electron will be hit and go out. gamma the least lah, because it's a wave. Yeah, because it's too small, so it can attack our DNA, our nucleus in our cell. So it will cause cancer lah. Okay, in comic, or the Hulk get gamma radiation, he become a superhero. But in real life, we get radioactive radiation, means we die lah, or we cancer lah. Okay, so now let's come back to. So actually here we got 3 radioactive decay: alpha decay, beta decay, gamma decay. Okay, then with nuclear reaction still got nuclear fission and nuclear fusion. This is your physics module, page 1, nuclear physics. Okay, so now can remember alpha actually is a helium nucleus. Beta is an electron, high speed one. Gamma is a rays or a wave. Okay, then how do we know it's decaying? Actually, you can see from the equations. Actually, here also show you it's uranium. It's uranium 238 and 92 proton. You can see that. It will decay out, become thorium. Thorium is 234. Yeah, this is 23. Thorium 234 and 90 means, see, if this is X, this is a particles P. So this is X, this is Y. You can see, you make an equation here, you can see very clear already. 238 equals to 234 plus 4. And you can see this line. 92 equals to 90 plus 2 lah. So actually this P will be helium-42. Okay. Thank you, Dylan. What happened? Okay. So it's here. Are we getting periodic table in Excel? You won't get it, but don't worry. Sure, they give you this too, so that you get what is the radiation. Okay, sure, they give you this too. If they don't give you like this, they might give you like X23892 become Y23490 plus Z. They ask you what is Z, something, right? And how is beta? Beta is a little bit weird because it got negative. Okay. Welcome. I know you're worried. So it's carbon 14. Carbon dating. Carbon 14 means got 6 proton. Become nitrogen 14, 7 proton plus P. So what is X? What is Y? Same thing, actually, you just need to make equation for nucleon number on top and proton number at the bottom. So we will get 14 equals to 14 plus 0. Yes, correct. This is 0, means no neutron and no proton. Then this one is 6 equals to 7 plus -1. Yes, -1. So apa ini? This is an electron. Okay, because this is your chemistry one. This one means the total number of proton plus neutron. This one is proton number, but no proton, it's just electron, so electron negative. Okay, this is how we write an beta particles. Beta particles 0, -1. Alright. So this is nuclear. Then gamma just ray, so nothing changed here. Just energy from cobalt 60 will decrease, become less radioactivity. Okay. Okay, so now actually this chapter only got 2 parts to calculate. One is half-life in graph and in a series. Another one is how to calculate nuclear energy by using this formula. Actually, not hard. The harder part is you must understand what is mass defect, and it's not in kg. It's not given in kg, so you need to change to kg first. Then you substitute, done. Happy ending. Okay. Then how to generate electricity in nuclear reactor? Actually, it's using the chain reaction come from nuclear fission. So actually, it's nuclear fission continuously. Okay, that's why the Chernobyl is uncontrolled. Then Chernobyl is a nuclear reactor, nuclear power plant, and it exploded. Okay. Now, okay, we look at nuclear fission first. Nuclear fission means we use a neutron. We use a neutron. We heat, but we don't say heat because it will go with faster speed. So we say bombard. Heat lah, but bombard is like more powerful. Neutron bombard on uranium-235. See, okay, bombard with uranium-235, and it will become less stable. So when it becomes less stable, for example, maybe I make it as carbon 14, carbon 14, carbon 14. Now, as you all know, carbon 14 is not stable. If unstable, it's going to explode. It's going to have sneeze when they are unstable. Actually, yeah, they try to radiate. They try to emit out radiation, alpha, beta, or gamma, to make them more stable. Okay, the nucleus not stable. They try to emit out radioactive radiation to make them stable. Nah, not stable, so they try to chop, take up. They split neutron, something like same thing. Okay, so 14 not stable. Okay, so when not stable, they try to split out something. So what they split out become what? They split out become chromium. Okay, sorry, boron. What is it? Boron. Ba bromine. No. I forgot what is it already. develop Br, Pa, and chromium. This is Ba. As explosion only occurs when the products of reaction can trigger more reaction. Actually here got explosion. Explosion means something go up and give energy. So this is the energy law. So this is the nuclear energy law. And this nuclear energy will change to light and heat energy law. Okay, so it will break into two bigger particles with 3 neutrons. Okay, then as you know, atom not only exists one, but normally exists in a lot. So these 3 neutrons will continuously bombard the other uranium nearby. See, bombard, then it will become another 3. Actually, this one they can draw for another one. So another 3. So actually 1 neutron will become 3. 3 will become 9. 9 will become how much? San So also about 27. That's in powers of 3. Yeah, cube. So become more and more. So next you can count. Means if you don't control it, the explosion will become too much and become a bomb. Okay, so the good news is we can control the neutron. Okay, if we don't want so many explosions at once, we just absorb the neutron or we slow down the neutron. We will learn this. This is the safety precaution here. So it will be controlled by what? Boron control rod and graphite moderator. And this is the uranium rod lah. Uranium rod means the explosion is here, but if you want to control the process, we must add on this too. Okay, so actually what we have heat energy to heat up the steam, heat up the gas and turn into steam. Finally comes to the generator. By the generator. Generator means it will generate electric current. So here got induced EMF. Then means actually what is this? This is from 5 chapter 4. Here got number 1 magnet. Number 2 coil or solenoid, wire coil or solenoid. Number 3 a force make it move. Okay, so apa itu? So generator actually using magnet to generate electricity. So inside it got magnet lah. Magnet actually got magnetic field. Keep cutting the coil. Then we continuously got electricity lah. Then if we use human resources, keep cutting like that, we tired. So some they use water to turn the turbine. So we call oh sorry, I circle wrong side. This is the generator. This is called the turbine. Okay, this is called the turbine. Okay, turbine means it's the things you keep cutting. You keep cutting magnetic flux on the wire coil. Okay, so this one you can go to check the video. Okay, we learned in Form 3 already, so you can search on. Actually, every generator finally comes to turns the turbine, turns the magnetic flux, cut the coil, and generate electricity. So here we need to know how to control. Okay, so now actually boron will absorb excess neutron. Okay, can you go up a bit like that? It's a must to memorize. I'll take screenshot. Oh, okay. Now, top part, you mean this? Okay, 1, 2, 3. Okay. This part, you mean this? 1, 2, 3. Okay, this part, 1, 2, 3. Then graphite actually will slow down speed of neutron. Slow down speed of neutron. That happens. Okay, so now we directly learn nuclear energy first. Quite easy if you understand the concept. Okay, so this one, 175, you'll do it as just copy lah, understand, copy and get the idea. Just copy and you will get it. 176. Complete the sentence and you'll get the idea. Okay, half-life, you just preview. No need preview. Like that, I think can finish the half-life today. Okay, we skip first. Half-life, we skip first. Okay, now nuclear energy. So nuclear energy is the result of what? The results of nuclear radioactivity. The two main nuclear reactions are nuclear fission. Fission actually means split. It bombards the uranium, split it into a few particles. And nuclear fusion. Fusion means they combine. Okay, then don't worry, not don't worry. Don't forget, we still got nuclear reaction of alpha decay, beta decay, gamma decay. So actually we got 5 nuclear reactions. But alpha, beta, gamma, the nuclear energy is very less. So we normally use number 4, nuclear fission. Number 5 is our sun. Okay, we normally use number 4, nuclear fusion, to produce out the heat energy. To mix water becomes steam, steam turns the turbine and generate electricity. Okay, nuclear fission is the process in which a large nucleus split into a few particles and release nuclear energy. Okay. Okay, so here actually is what I said just now. Okay, and what I said just now. So actually, this neutron will bombard it into the uranium, and now the uranium become 236 and 92. Means we're embedded inside, so that it will be not stable. When they feel unstable, they will feel the ones achik. Achik means the ones will split into a few particles, right? So normally we don't write this. That we actually we can skip this and we split into Ba bar banana no lah. Okay, plus chromium 8938 plus 3 neutron. Okay. Oh, sorry. Neutron is 10. Neutron is 10. Means one proton without, sorry, one neutron without proton. But here got 3. 1, 2, 3. Okay. Okay, so now, but I want you to have a concept now for the 5 chapter 6. Ha, I want you to have a concept now. So in the beginning, it's like original. Like one uranium is like one vase. But when you break it up, it will become 1 piece, 2 piece, 3 piece, 4 piece, 5 piece, 6 piece, 7 piece. Okay, but it still got some powder-like form that you cannot attach back. So the powder-like form, we call it as mass defect. Means even though you join them back in a big piece, but still got some part disappear already, missing out. So some part missing out, the powder like missing out. Powder like missing out means missing one. So the part that missing out for mass defect. Okay, so this mass defect will turns into huge nuclear energy. Okay. If you are interested, can go watch Oppenheimer. How to pronounce the person who helps to invent up the nuclear bomb. Okay, so still got some mass missing out. You total it up, you'll find out they are not equal. A little bit missing out. So the missing part called mass defect. And mass defect will turn into nuclear energy. Yes, that's the greatest formula in 20th century, which made up by Einstein. E equals to mc squared. So he said the missing mass called mass defect times the speed of light in square of light. Then you will get the nuclear energy. One is very small, but if it goes through a chain reaction, it will be a huge number of nuclear energy and can bomb the Hiroshima and Nagasaki. Okay, so now comes to nuclear fusion. What is nuclear fusion? Nuclear fusion is the combination, or we say fusion, of two lighter nuclei to form heavier nucleus. Nucleus. I believe you know. You learn this in Form 3. Stimulus means one change. Stimuli. So this is singular, this is plural. And I believe you remember alveolus, singular one, alveoli, singular. And I believe you know locus, one, singular, and loci, plural. And last year we learned Kepler's first law. All planets move around the sun in elliptical orbit as sun as one focus. As one focus, singular. Two focus we call foci, so plural, right? So two we say nuclei. Okay, one we say nucleus. So combine two light nuclei become a heavier nucleus. Okay. So now how is it? So actually this is the fusion in the sun. Why we get heat energy from sun? Because sun got nuclear energy, always bomb there, bomb here. Okay. So it's here got, this is hydrogen. I believe you all remember hydrogen is 1, 1. Means it only got one proton. But we also got radioisotope. Isotope, you know lah, different neutron. So this is 2, 1, called deuterium. If you don't remember the name, how? Never mind, you just remember this enough. So this one got 3, called tritium. Okay, so 2, 3, they will combine, fusion, become H5, 5, 2. He5, 2. They become 5, 2, helium. But you know lah, helium-5, 2 not stable lah. So they decide to kick up one neutron. Okay, then left helium nucleus is better lah, stable. So this is stable lah. So this is unstable nucleus becomes stable nucleus with the energy lah. Okay, so the equation like this, 2, 1 plus 3, 1 become He5, 2. You want to skip this step also can. Directly become 4, 2 is more stable plus neutron 1, 0. Okay, so make a summary in case you forget. Actually, proton is proton 0, 1. Electron actually is E, 0, negative 1. Neutron actually is 1 neutron and no proton. Okay. One more time. Up here, Up here actually is the number of proton and neutron. Down here actually is proton number. Okay, so down here is proton number. So see, only proton got 1, electron is negative, neutron no proton. Okay, the energy source in the nucleus in the helium is the result of fusion of hydrogen nuclei. Okay, so now same thing. When they combine, also they need to lose some mass. The loss of mass, we call it as mass defect. And this mass defect turns into nuclear energy. Okay, now let's count. So this one you all do lah. Formula is E equals to mc squared. E is nuclear energy. Don't worry, exam formula is given. Mass is mass defect. Nuclear energy in joules. Mass defect in kg. C is speed of light. Don't forget the square. Speed of light in meter per second. Now, okay, so because of the mass of atom and subatomic particles means proton, neutron, electron. So small. So convenient unit will be used is called AMU. We don't use kg because kg will be a big number. Up by the AMU. So AMU called atomic mass unit. AMU called atomic mass unit. Okay. Like for example, your body mass. Normally we say what? We say 50 kg. When you tell people, I have 50,000 grams. Not logic, right? It's not user friendly. So same thing as this. It's too small, so we use a prefix, something like a prefix. Okay, so this one is a little bit long, so I make it easy. Now, actually, it's same as your molar. Okay, like 1 dozen of pen equals to 12 pence. Can you please tell me 0.75 dozen of pen equals to how many pence? Thank you. 9, yes. I believe you will do this. 1 is 12, right? So this is 0.75 times 12. You will get 9 pence. Okay, so same thing lah. No matter it's okay. So actually 1 AMU equals to here 1.66 times 10 powers of negative 27 kg. 1.66 times 10 powers of 27 kg. So same thing lah. If I have 0.75 AMU, what should I do? 0.75 times 1.66 times 10 powers of 27. So kg. How much? Where's my calculator? Chị ủ trứng ít tiền lên số十1.245乘1027K negative, sorry, negative. Means what? Means it's 1, 2, 4, 5. 1、2、3、4、5、6、7、8、9、10、11、12、13、14、15、16、17、18、19、20、21、22、23、24、25、26、27、28、29、30、31、32、33、34、35、36、37、38、39、40、41、42、43、44、45、46、47、48、49、50、51、52、53、54、55、56、57、58、59、60、 0.000000027 places. So it's too small if we count in kg. That's why we count AMU. It's a long story to tell you how to get 1 AMU. Actually, it's a mass of 1/12, 1/12 of the mass of carbon particles. It's like a relative. Okay, so for for example, okay, let's say this is me. I'm 50 kg. Okay, so now my niece is 25 kg. Okay, so I say I am 1 AMU. So she is half of the U. Something like can get the idea. So like my brother is about 100 kg. So I say my brother is 2 AMU. So once you get the AMU, then you change back to the kg lah. So it's this concept lah. Can say like AMU represent the ratio. Can say that? Can say that. Like 1 dozen is 12. So a number represent, this one represent a number. Then if I say I have 0.25 dozen, means 0.25 times 12, that's 3 pence. It's like a ratio, can say that. Okay. So wherever AMU you get, you times back kg, you will get back the kg lah. So because the atom too small, we cannot use kg. We normally write in AMU. UJA is BM, this is BM. Okay, now let's see this. Page 184. Radium-226 undergoes alpha decay to become radon-222. Equation is like this. So as I told you before, actually it's same like your chemistry. This is before nuclear reaction. This is after, so material product. So before and after, there will lost some mass. The lost mass called mass defect. How much mass is lost? So look at this. Radium, Ra, is 226.025406. Become radon 222.017574 plus 1 helium So you'll find out if you plus these two together, cannot equals to this, sure got something missing. So every time we find mass defect first, delta M. The mass defect will be the radium before reaction, the radium before reaction. AMU, you also can just write U on it. AMU, you also can just write U. Okay, minus the product. Actually, quite easy lah. Just long number makes you difficult lah. Minus this two, then you will get this is your mass defect lah. So this is your mass defect. But remember, it's in AMU, so it's a ratio, not the kg. So we times this one. We change it back into kg in this way. See, negative 30. Then we substitute back E equals to mc squared. This m is mass defect, so we substitute back here. Don't forget, this one is speed of light bracket square times 10 power of 8 bracket square. Why I need to remind you? Because actually I always make the mistake. I press, you minus first, you get this, you substitute, you press, so that you got muscle memory, right? So you will get this. I press calculator, I get 5.229 times 10 powers of negative 3. Then times 1.66 powers of negative 27. So I will get 8.680. 14. Yep, 0.14. At least 3 decimal. Then times c squared. 3 powers of 8 bracket squared. Yeah, I will get this 7.812126. At least 3 decimal, 4 better. 7.8121 times 10 powers of negative 13 joules. Quite easy, right? Just the number is long. And don't forget, change AMU back to kg. Okay, so, okay, guys, here. So now this one. So, okay, sometimes they give you in equation. Sometimes they give you like in the diagram. Okay, so you can see actually before reaction, before nuclear, reaction is 1 neutron plus 1 uranium. This is before. So you plus these two mass minus after. So remember, before minus after. So this one will be 1, 2, 3, 4, 5. But I think your answer just count 2 neutrons. They didn't count 3 neutrons. But now I want your count 3 neutrons. Okay? Your answer count 2 neutrons only. Okay, so your mass defect is delta N equals to 1 neutron. Let's see. 1 neutron. Okay, if you don't want to write it directly, count also can. So actually it's 1 neutron plus 1 uranium minus 1 barium plus 1 chromium plus 3 neutron. Đấy, you do minus 3, 3. Now we count 3. Your answer count 2 only. Now we count 3. 3 neutron. So, 1.03加上235.043923减掉143.924减掉89.919，再减掉3个1.00。1.66666。Oh, become negative. That's why they put 2. That's why they put 2. Yeah, sorry. We make 2 lah. We make 2 neutron only. That's why they make 2. Okay, again. 1.00366加上235.3924减掉89.91938减掉143.92291，再减掉2个1.0。Sorry, 0.196779。You make 4 decimal places only lah. Times this one, 1 AMU is this. So 1.66 times 10 powers of negative 27乘以1.66 powers 减27，so 是3.2666， sorry 2665乘以10 powers of 减28。Okay, so this is kg after you times it. Then, don't forget this is just mass defect. What we want energy. A equals to mc squared. So, 3.266乘10 powers of 减28乘以3 powers of 3乘10 power of 8 square. Yeah, I clear already. 3.266 power 1028乘以 I remember bracket. Remember bracket. If you don't bracket, you will just square 8 only. 3 power 8 bracket square. So 2.9399或者是93982.93999 correct. Make sure you get your okay, done. So I tell you all like that only. Just equation change, nuclear reaction change. Or get the mass effect, change to kg, substitute E equals mc squared. Don't forget bracket 3 times 10 powers of 8 bracket squared. That equal that. Looks very less, huh? But you don't forget this is for one atom only. One atom. Some more nuclear bomb is huge number of atoms. And some more it got chain reactions. So I don't know billions or trillions or I'm not sure. Okay, so all like that actually, so you just sum up these two minus these two. You use the mass before minus the mass after. The mass before minus the mass after in AMU. Then change back to kg. Subs E equals to mc squared. Okay, so you do this one you do 185. 186. This one you can refer answer or refer textbook. So actually here got this one. Here got uranium rod, boron, and cadmium and graphite. And actually coal, hydropower, nuclear energy, all generate heat in different way, but finally in power plants, inside got turbine. Turbine turns the magnet. The magnet got magnetic field. Keep cutting on the coil, then generate electricity lah. So this one your homework lah. Okay, this one your homework lah. Oh. If you are not sure, just copy answers. If I'm not sure, just copy answers. But this one is important. Okay, so now the field is uranium better. Then the wall should be thick. Control rod should be boron or cadmium. Boron or cadmium. Moderator is only graphite. Control rod is to absorb excess, too much neutron excess. Moderator is to slow down. It's a must to memorize. To slow down the speed of neutron. Okay, concrete wall can block like let the radiation won't penetrate it. So uranium compared with thorium it has a huge nucleon number. Huge nucleon number means can use longer, means can have more nuclear reaction, means can have more fission. Okay, so now come back to the half-life. Okay, and I tell you what, 2023 SPM, they give two graphs like that, but they didn't give you the name. So you need to name it yourself, X and Y. Okay. Yeah, it's a very huge mistake from the paper. They didn't label, so you label yourself. Okay. So we still have around 25 minutes to solve the half-life. Actually, you all also learned half-life in Form 3 already. What was the reason for the concrete wall? To block the concrete wall to block the radioactive radiation. So when I'm talking about radioactive radiation, I'm talking about the alpha, beta, gamma. Teacher, concrete say absorb high temperature. Can also to block the radioactive radiation. Concrete also can to withstand high temperature. Okay, high temperature of power plant. Okay. Actually, is we use it to block, like just now the liquid block the radiation. Is that for the reason? Yeah. To block more, thicker so thick concrete, so block more to withstand higher. Please add adjective. And don't forget the mid-year, I purposely put number in your choice. Don't write number, write more or less, greater or lower, right? And you can refer back answer. If you have no time to do one by one, you just copy lah. Copy first. Calculation also, if you understand already, you just practice, practice press calculator until you get the muscle memory. Don't use eyes only, press, so that you got muscle memory. Okay. So I know that every subject also rushing. So at least you try to press. Train your eyes to take which mass plus minus before mass before minus mass after. Change to kg subsin E equals to mc squared. Done. Quite easy. Okay, now half-life. Okay. Actually, half-life also for me easy to understand. Half-life. Okay, so actually the importance is we look at the, for example, centripetal force. So the important one is not centripetal. Gravitational force. Okay, what is the symbol for gravitational force? Is it G or is it F? Thank you, Bethany. The rest? Yeah, actually it's the F. So actually in physics, physics, the second word is the physical quantity. Second word is the physical quantity, not G. Like for many people confuse the gravitational force is G, no, it's force. The same thing as half-life. The second word is your physical quantity. So life actually means the time. So how many years you live means you got how many years of life lah. So the half-life of radioactive nuclei is the time taken for the number of undecayed nuclei to be reduced to half of its original. So sometimes we also say for the number of undecayed nuclei. Sometimes you also say for the mass of undecayed nuclei. Also can say for the radioactivity. What else? I think these three only. Yeah, the mass, the number, or the radioactivity to reduce to half its original. Okay, so you can see actually radiation continuously emits out radiation. But until some time, it will become half of its original. Okay, after one half-life, the number of nuclei not decay will become half of its origin. Okay, the rest you copy lah. This one will come back later. No, so this page 178, you can see here. So for example, in the beginning, there is You must be careful. Here is 120. I will always look back to the unit. But this is not the unit, but they said 1,000. Means actually 120,000. Means originally. Okay, decay. Decay means they lost to surrounding already. They lost out already. Undecay means they still stay inside. Means how much is still left, right? Means can imagine like still in your hand, right? Okay, so it's 120,000 become half and become half and become half and become half again. So with the time of 1,600 years, it will decay become half. With another 1,600, it will decay become half. 1,600 become half. 1,600 become. Okay. So it's now this is life. So x-axis will be the life. Y-axis will be the half activities. So after this, we left 60,000 means 60,000 lost out already. So after that become 30,000 means this one go out already. Decay out. Lost means decay out. So this one left like this. Okay, how will be the problem looks like? Okay, so from graph like this normally it's like this. They give you this graph. They ask you how to find half-life. So if how to find half-life. 2、4、8、12。Okay, let's say like this. Let's say like this. They will ask you how to get the half-life. So you get original 120 become half 60. That let's say this is 2 hours, 4 hours, 6 hours, 8 hours. So your half-life we write like this. The period of half means the time of half is 3. Let's say this is hours. So 3 hours, right? Then now how to calculate? We can use this formula or we can use this formula or we use a decay series. Actually, I prefer you all do decay series, but up to you. Okay, apa itu NO? NO means original value of radioactive substance. Means like just now the mass, the radioactivity, the undecay number, undecay number. Okay, then N is the numbers of half-life. Okay, this one would be half-life. The half-life in sometime. And N is the undecayed. N means undecayed. Radioactive. Radioactive. Radioactive substances. Undecayed means the left one, the leftover one still stay inside, not yet escape out. Okay. So then now example. Now, for example, from the graph, the half-life, this is a little bit, difficult, but you also can use another way, but you also can do this. Original 250,000 nucleus. Okay. So become half is 125,000. So it's around here. It's the center here. So we draw a line. We can draw a line and touch. Draw a line, touch the graph. Draw a line from here, touch the graph, and go down. So it's around 1、2、3、4、5、6. So it's around 61 or 62. Yes, 不是，也不是，这是1、2、3、4、5、6、7、8、9、10。Okay, it's around that. Let's say 62 seconds. Okay. This one is they use here the total number one. Also cannot. But then the exam will be easier. Just draw like that enough. Okay, so now the question is the ratio after 220 seconds. Okay, so let's say your our half-life is 55 seconds. Okay, so means number of undecayed nuclei means what's left. This is decay means already radiates out. Radiates out. So we can use the formula N equals to half N and half life N and not. Okay, so half original is 250,000. 250,000. But the question is, what is N? Okay, so now 55 seconds means how after one half-life, 55 seconds means after 220 seconds got how many half-life? If you have no idea, do this like 250,000. I use arrow to show one half-life. One half-life 55 seconds. Then I continue first. Two half-life would be 110 seconds. Three half-life would be, 55 plus 55. So 1, 1, 2, 165 3, 4, 2, 2, 0. You can see I got 4 arrows. Yeah, this is the series. I got 4 arrows means I got 4 half-life. 55, 110, 165, 220. So let's press calculator. Half bracket, half square. Sorry, powers of 4. Powers of 4 times 250,000. We will get 15625. Okay, we will get 15625 undecayed nuclei left. Means the decayed one is original minus 15625 equals to 234375 nuclei. Decayed nuclei. Decayed means out already. This one's still in. So the ratio of half-life is 4. The ratio of what number of decayed to I think they write something wrong. Is the number of undecayed to decay. So undecayed to decay would be 15625 dot dot 234375. So 15625 divided by 23437. So 1 to 15. Yeah, I believe you feel blown up by this. So remember, undecayed means still left. Decayed already out. Radiate out. Okay, now let's see. This one, okay, this number 2, you just cancel something missing here. Okay, now number 3. Radioactive substance Z has half-life of 20 minutes. So let's write half-life is, let's write in 4, yeah. Half-life is 20 minutes. How many half-life has it undergoes in 1 hour? How many? 3. Thank you. Yeah, you can. Yeah, thank you. Yeah, you can use either 1 hour 60 minutes divided by 20 minutes means 3 half-life, or you can do this. 1 is 20, 20, 20. So you got 3 half-life now. So here original, half, half. Okay, now what is the fraction of original mass that has not decayed after 1 hour? Okay, when they ask about fraction, they are actually asking you to make original as 1. So after 3 half-life will become half divided by 2, half divided by 2 again, 1/4 divided by 2 again, 1/8. So what is the fraction of the original mass have not decayed, means left, still stay here after 1 hour? All right. Now, excellent question. This is module. Now, same thing actually. Actually, same thing. Now, this one. For example, now this is on top. This is on top. And this is at the bottom. Now, same thing lah. Blah. Calculate the energy release. Same thing lah. This one. This is page 119. Like page 119. Intervention. Half-life of cobalt-60 is 5.27 years. Calculate the time taken for the activities of cobalt-60 to reduce to 6.25% of its initial value, original value. So when they ask about percent, means you can make from beginning. Original per initial means 100%. But sometimes they will give you the number, the mass, reactivity, or they just give you percent or fraction. So 100% become, you do until you get 6.5, half 50, half 25, half 12.5, half 6.25. Ta-da! So now what? Now you get 1 half-life, 2 half-life, 3 half-life, 4 half-life. So your time taken is 5 half-life. So it's 5 times 5.27 years. It's become 26.35 years now. Or if you want formula, once you use formula, n equals to half n and not. Formula given or not? I think so. Yeah, formula is given. Okay. Formula is good. So left 6.25% left. Reduce 2 means still left this. And half. Original is 100%. N is from here to here is 1, 2, 3, 4 half. So actually means if you don't want to draw this, you make it as n. Then you move it as 6.25 divided by 100 equals to half n. How to mix the unknown n down? Yes, you are right. Logarithm. Yeah, we'll get n from logarithm. Okay, if you feel, apa itu, I forgot already. Okay, never mind. You just draw the series out instead. Just draw the series. Okay, then same thing actually. Okay, so everything the same. Now, determine the half-life of S. So actually this is original for, remember, half life. So they want the life. They want the time. They want the time. So half is 4,000 become half. And draw like this. And draw like this. Must show this file. I think this is SPM 2017. Yeah. So it will be 5,000 years. Okay, so actually this graph also quite easy to see, but so far I never see this in SPSS. So you can see when the line like that, this is nucleon number, this is proton number, means nucleon number, proton number. So when it goes down like this, means nucleon number goes down 4 minus 4. Proton number goes down 2. So actually when they go like this is alpha, means helium particles. So this is 1 alpha, 2 alpha, 3 alpha. Then when they go like this means what? Goes in front become more proton, means it's electron. Electron negative, but proton would be positive. So actually here got how many alpha? 1, 2, 3. 3 alpha, beta got 2, 2 beta. So what they are asking? Wow, this one. This one you can write, right? I cannot. So determine the alpha particles and beta particles, 3 and 2. Okay. So remember the single one alpha, the horizontal one beta, right? Then same thing actually. The same thing only. Okay. So try to finish it. If you really no time, just copy answer first. Really, you can learn from answer. Okay. I know you're all rushing. Yeah. I know you're tired. Yeah. A lot of subject. Yes. So just copy. Okay. Now that's all for today lah. Then next week we can start chapter 5 already. Okay, any other question? Okay, if no question, next week I'll try to finish 5.1 and 5.2, thermionic emission and diode. 5.3, I think one more will be done and almost done. Okay, thank you everyone. Bye-bye. Okay.